Our third equation of our Suvat or motion equations comes from taking the first two equations, solving the first one for time, and then plugging it into the second one. If you remember, the first equation, let's select a pen here, was V equals U plus A times T. The third equation, or I'm sorry, the second equation was S is equal to UT plus 1/2 AT squared. So we're going to solve this equation here for time, which is a pretty simple operation. V minus U is equal to A times T. And then basically V minus U divided by A will equal T. We're going to take this and plug that into here. I'm going to try to do it with this color combination. So I have S is equal to U times V minus U all over A, and then plus 1/2 A times V minus U all over A, but squared. So we're going to stick with the blue color from here on out, but you can see that this is a square term, that's a regular term. And now we have an equation that doesn't involve time, but this is really pretty messy, and we need to kind of clean this up a little bit. So the first thing we want to do is kind of simplify this by making this all square. Let's get rid of this square term out here. So I'm going to have a 1/2. Sorry, let me get rid of that too. 1/2 A times V minus U squared all over A squared. And you kind of notice that one of these A's will cancel off, so that gets rid of the square term down there. We can continue to bring these other parts along. This becomes U times V minus U all over A. To get rid of, we want to kind of clear fractions if we can. So we're going to multiply the whole thing times 2A. So that gives us 2 times A times S is equal to 2U, this A canceled off, that A, times V minus U plus 1/2 V minus U in parentheses squared. It still stays pretty simple. I'm going to slide down to give myself just a little bit more room. Now we got to kind of work and clear and combine like terms and stuff like that. So I end up with 2UV minus 2U squared plus 1/2. Now we have to continue to work these out here. I'm sorry, this 1/2 is gone because we canceled that off with the 2A. That's a kind of a bad mistake, but we caught it. So we're still good to go. So now all we really have is this right here. That's going to simplify to V squared minus 2UV plus U squared. Now you can kind of see a lot of these things are exactly the same. The 2UV here cancels out the 2UV here. We end up with a negative 2U in a U squared. So this goes away and this goes away. And what we really end up with on this side is just simply V squared minus U squared is equal to 2AS. The way this is traditionally written is V squared is equal to U squared plus 2 times A times S. So that's our derivation of the third equation. One of the things we wanted you to do is kind of watch how you can take two equations when you don't have a don't have a variable that's solved or given for either of them. In this case, well, to kind of slide back up, we solved this for time, and then we plug the time in here. So we have a common variable that's unknown in each equation. We've solved it for one, plugged it into the other, and then we're able to come up with a relationship that does not depend on that time variable. And that's our derivation of the third equation. The next variable, or the next video we'll work with, will show us how to use these equations.